Anisatul, Harun, Intan, Khairun Anwar, Khorgwi, Muhammad Imran, Muhammad Fitri, Muhammad Abdul, Muhammad Aidil, Muhammad Amir, Muhammad Faizi, Nasalni, Nur Hidayah, Nur Ashikin, Nur Fatihah, Nur Anis, Nur Aini, Nur Aisyah, Nur Alina, Nur Fatihah, Nur Zahira, Syarifah Hanisa, Umi Kaltum. Oke ya, saya bagi satu example before we can start ya. Okay, thank you very much. Before Wednesday night, I have given three example you can study, and then after that the all lesson not related to the three-phase synchronous generator I'll send using WhatsApp group ya, yeah? And also this video lah. Ini nampak ada yang record kan? Okay, nah so ini satu ada example ya saya bagi ya. This example related to the phasor diagram. Nanti ini saya masukkan dalam lecture note. Ya, masukkan dalam lecture note. Related to apa nih phasor diagram. Sebab nanti test 3 ada satu soalan yang mengandungin phasor diagram. Ya. Now please look at this example. 400 active volt 50 Hz Y connected 6-volt synchronous generator has a per phase synchronous reactance of 1 ohms. Its full armature current is 60 ampere at 0.8 lagging power factor. This generator has friction and windage losses of 1.5 kilowatt and core losses 1 kilowatt at 60 Hz at full load. Since the armature resistance is being ignored, assume that the I power to R losses is negligible. The field current has been adjusted so that the terminal voltage is 400 active volt and no load. The questions are, the first A, what is the speed of rotation of the generator? B, what is the terminal voltage of this generator if the following are true? The first, it is loaded with the rated current at 0.8 power factor lagging. It is loaded with the rated current at 1 power factor. Unity means it is loaded with the rated current at 0.8 power factor leading. See, what is the efficiency of this generator? Ignore the unknown electrical losses when it is operating at the rated current and 0.8 power factor lagging. 0.8 ya. How much sub-torque must be applied by the prime mover at full load? How large is the induced counter torque? What is the voltage regulation of this generator at 0.8 power factor lagging, 1 power factor, and 0.8 for the leading power factor? Nanti for the test 3, for the test 3, the question is also calculate the speed in the unit radian per second. We can the first calculated from the RPM, you can convert to be radian per second. Okay, and then for the B, this one is we calculate the terminal voltage. Yeah, terminal voltage. Terminal voltage. Test 3, you draw the phasor diagram. When we want to draw the phasor diagram, we can find the value of internal generated voltage, EA. Yeah? Okay. Look at this one is 400 active volt. The synchronous generator connection is Y. Yeah. Y connection. And then the voltage 400 active volt. Yeah, it means it is the line to line voltage. Yeah, line to line voltage. Same. Ya, nantinya ya for the test 3, I give the waveform ya, waveform. Ini kan dibagi. Kalau dekat ini kan dibagi nilai lihat the value of the line voltage is given by this one. Saya bagi satu waveform. Ya, nanti ada hintsnya ada lagi. Ya, hints ada. Lalu the waveform same. This one is line voltage. Ya, line voltage meaning line to line voltage. Ya, this one. Nah, so the number of volt is 6. And then the XS synchronous reactance 1 ohms. Yeah, and then the current flow through the load at the power factor lagging 0.8 is 60 ampere. Yeah. The mechanical losses of this generator is 1.5 kilowatt, and the core losses is 1 kilowatt, and the electrical losses is ignored. Yeah, this one is ignored. Now the A, we want to find the speed of rotation of this generator. Yeah, now so we can see the answer. Ini question ini ada dekat ini ya, ada dekat reference book itu yang dia punya author J. Chapman ya, saya ambil daripada situ juga. Okay, now so if the terminal voltage is given by the 400 active volt, in here it means it is the line to line terminal. Remember there are you have to remember related to the voltage and also current. The first, if we have value of the RMS or the peak value, we have relationship between the peak value and RMS value. Now so we know that the peak value is equal to sines to RMS value. Ini ya, kenapa? Kena ingat. Okay, and then if we have mentioned line voltage or the phase voltage, same, we have the relationship between line voltage and phase voltage. It is for the Y connection. If the Y connection, line voltage is equal to sines 3 phase voltage. Remember for this case. But if the generator is the delta connection, line voltage is equal to phase voltage. Ingat ya, keadaan-keadaan macam ini ya. Okay, because this one is line voltage for the 400 active volt, and then remember phasor diagram, is drawn in the purpose. Same when we want to draw the equivalent circuit, purpose equivalent circuit meaning purpose ya. Now so you have to find the value of purpose value. Okay, I means untuk yang ini when we have the value of terminal voltage is 400 active volt. Now, so we can find the phase voltage. Yeah, phase voltage is equal to terminal voltage. Yeah, terminal voltage in here is line to line voltage, yeah, because it is Y connection. Y connection. So line to line voltage. So phase voltage is equal to terminal voltage or line to line voltage divided by surge 3. Maka kita ada diperolehin the phase voltage is 480 divided by surge 3 is equal to 277 volt. Ya, this one ya. Nah, this one is phase voltage. Ya, phase voltage. Ya, from this phase voltage we can draw the nantinya kita boleh gambarkan the phasor diagram and also equivalency curve. Okay, and then remember the phase voltage is always as reference, ya, reference point. Ya, meaning reference points the angle is 0 degree. Itu kena ingat ya. Nantinya kalau mau kita melukis, if we want to draw if we want to sketch the phasor diagram. Ya. Okay, and then yeah, in the condition, yeah, remember, in the condition if the generator is not connected to the load, meaning the generator is open circuit. In the condition of the open circuit, there is no current flow through the armature resistance, and also there is no current flow through the synchronized reactance. Means the phase voltage is equal to internal generated voltage ya. Ya, so keadaan ini open circuit, EA is equal to phase voltage is equal to 277 volt. Ya, ya. Okay. Okay, the A question. Question A, what is the speed of the rotation of this generator? Now, this value we can find from the formulation synchronous or rotation rotor speed. That formulation is given by this one, and S is equal to 120 F over P. Yeah, F is given in the question, is also P is given in the question. Yeah, F is 550, yeah, and P is 6. So speed rotation of this generator is equal to 120 multiply 50 over 6. We obtain 1000 RPM, yeah, revolution per minute. Now this value we can convert to be in radian per second. Yeah. Nah, so we can write in here. Nah, sama ya nanti if in the question test 3, find the speed rotation in radian per second. Nah, so you have to convert the value of speed ya from the revolution per minute to be radian per second ya. Nah, how? Remember ya, ini kan simple. 1000 revolution per minute. Revolution. Satu revolution. Meaning one cycle. One cycle is equal to 360 derajat. Ya, 360 degree. Ya, or is equal to 2 pi radian. Nah, so revolution is equal to 2 pi radian. And over minute, 1 minute, 1 minute you have to convert to be second. You know 1 minute is 60 second. Now, so this one is to be 60 second. Means 1000 should be multiplied to 5 radian over 60 seconds. Now we obtain the value of mechanical speed is 104.7 radian per second. Yeah, this one, yeah. Okay. Okay, then B, yeah, for the B, what is the terminal voltage? Yeah, what is the terminal voltage? VT. Yeah, what is the terminal voltage? VT. Or line to line. Yeah, this case line to line or terminal voltage. Yeah, the case if the loaded with rated current, current tetap ya 60 ampere in here, but the difference in the uh, power factor, yeah, 0.8 lagging, 1 and 0.8 leading. Yeah, lag meaning yeah the current lags voltage by berapa degree. So dia lead current leads voltage by berapa degree. Ya, nah degree meaning in here you can find ya cos arcus cosinus 0.8 for example this one ya. Okay, now so we calculate the first for the power factor 0.8 this one. Yeah. Okay, now we know that when we the internal generated EA, per phase, this one per phase, and then current flow, when the current flow, meaning the condition is loaded to the load, current flow, the current is 60 ampere. Now, so we know that EA is equal to phase voltage, phase voltage plus JXS IA plus IAR RA. Yeah, this one, it is general formulation. Yeah, I repeat again. EA is equal to phase voltage plus JXS IA plus IA RA. But in here, that has been mentioned in the question that IA RA is ignore, is ignore. Ya, nanti dalam soalan tadi ignore ya, dalam tes tadi ignore, dia bagi kena dikalkulate. Okay, now so the first you have to find the value of JXSIA. XS is given by 1.0 ohms, and then IA. IA is 60 with the angle. Remember, for this case lagging. Lagging. Meanings current lags voltage by how many degree? The degree can be obtained from because this power factor is 0.8. The angle is theta is equal to cosinus inversely 0.8. Now we obtain 336.87. And then because the power factor lag, lagging, meaning current lags voltage by 36.87. Nah, dia punya angle negatif ya. Dia punya angle negatif. Nah so the last we have obtained the value of JXSIA is 60 angle 53.13 degree. Means this one ya. J itu kan angle 90 degree. Nah, I write here to be 1 angle 90 degree. Multiply 60 angle minus 36.87 degree. Kalau ini kan step by step to be solved. Meaning for the angle 90 minus 36.87. Nah, this one lah 53.13 3 volt. Yeah, this one. Now, so we can, if we want to draw in the phasor diagram, remember the first you have to draw the, ini ya, apa nama, uh, itu kalau nanti kalau in the question apa nama dalam soal nanti final tes ya tes. Tapi kalau yang dekat sini kan, in this case you want to find the value of phase voltage ya, phase voltage related to the terminal voltage ya nanti ya. Nah mananya kalau lah we illustrate here because we want to find the value of phase voltage ya, the general we can draw ya phase voltage is as reference here ya, meaning the angle is 0. And then after that we obtain the armature current yeah, that is given from the question. IA is 60 ampere, but for the angle minus 36.87 degree, yeah, it is theta. Yeah, theta. And then because IARA is ignored, so selalunya IAIA, IARA, and also JXSIA, yeah, they are part of the voltage or voltage drop. Now, so for the JXS, yeah, is always drawn, yeah, is perpendicular. Maknanya ini kalau kita perpanjang sini, kalau tarik perpendicular sampai ujung inilah, kenakan ujung the end of the vector phase voltage. Nah ini ya macam ini. Lalu ini kan last, and then the total vector of EA is the initial vector from phase voltage, and then the end vector of the JXIA. Ya nih. After that, we can like projector, meaning we have the line here. Yeah, the line here, and then if it is horizontal line and this one is vertical, I means you draw one triangle, yeah, this one with the angle perpendicular here. Yeah, now so the line here is reflection of the vector JXSIA. Now so meaning this line is XSIA sinus theta. Yeah, theta here, same theta here. Yeah, 336.87. And line in front of the angle, yeah, is sinus. And beside of this angle is cosinus. So this line is XSIA sin theta, and this particle line is as projection of the JXSIA. Yeah, this line is given by XSIA cos theta. Okay, now so look at this triangle here. Here, here. Yeah, I repeat again. Look at this triangle here. Yeah, starting here, 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 and perpendicular in this point. Yeah, means yeah, based on the Pythagoras rule, yeah, EA power 2 is equal to yeah the length of this line power 2, meaning P base plus IS IA sin theta power 2 ya ini ya, plus ini yang ini, this line XS IA cos theta power 2 ya. Mana saya dapatkan inilah, kita perolehin ini daripada angle ini. Oke. Okay? Nah, so we can derive, after that we can obtain the value of phase voltage. Ya, bla 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 bla. The last we can obtain the phase voltage is equal to 236.8 volt. Yeah, this one. And then remember, it is phase voltage. Yeah, the question is terminal voltage. Terminal voltage means line to line voltage. Now, so you have to find the value of line to line voltage. Ya, line to line voltage equal terminal voltage is equal to surge 3 phase voltage. So surge 3 multiply ya 260.8 ya is equal to 450 410 volt. Ya, this one ya. Ya. Now this one it is for the power factor lagging. Now for the power factor unity. Ya, unity. Unity means current, phase current, or IA current, and phase voltage are in phase. Ya, are in phase. Ini ya, kalau kita tengok ya. Ini are in phase. So the vector of JXSIA can be drawn, ya, starting from the end of the vector phase voltage and the perpendicular, ya, selalunya perpendicular, ya, like this one. Now so we can find the value of phase voltage. Yeah, this directly we can find, yeah, that based on the triangle here, trapecular here. So EA power 2 equal to phase voltage power 2 plus IS IA power 2, ya, this one, ya. Okay, now so we can find the phase voltage is equal to 270.4 volt. Okay, now so terminal voltage same should be multiplied as 3. Okay, so 3 multiplied 270.4 is equal to 468.3 volt. Ya, this one. Oke, yang ketiga B3, ya, B3, the power factor is leading. Ya, leading means IA leads phase voltage by theta. Dan theta ini adalah yang tadi ya 336.87 36.87 degree. Ya. Nih. Nah, sekarang ya you can find the value of this phase voltage. Ya. Ini sama ya. If we draw like this one, ya, the first you can draw the phase voltage here. Ya, the phase voltage. After that you can draw the IA with the angle 36.87. Yeah. Okay, and then yeah, now so we can look at this angle, this triangle. Yeah, starting here, here, and then perpendicular here. The angle here. Yeah, same, yeah, this one. Now so it is XS IA sin theta. Yeah, the side line in front of the angle. Yeah, and then this one is XSIA cos theta. Because we want to find value of EA for the angle here, here, perpendicular here. Yeah. So yeah, we can find, ya, ini P phase ini ya. P phase the totalnya kan sini. Nah, so the angle, the triangle here is equal to EA power 2 is equal to phase voltage here minus XSIA sin theta power 2 plus this line. Ya, XSIA cos theta power 2. And then after substitute the value of EA, phase voltage XSIA theta, you can find the value of phase voltage. Yeah, it's around 308.8 volt. And then same terminal voltage should be multiplied by the surge 3. So surge 3 multiplied 308.8 equal to berapa nih, cek balik ya, 535 volt. Oke, ada apa-apa sebelum kita lanjut? Ada apa-apa, Umi Kaltum? Ini mana nih? Hakim. Saya
Okay,
ini.
sir. Okay, sir.
Oke, Ahmad.
Doktor.
Ya, saya. Ya, apa dia? Siapa tadi? Halo?
Doktor.
Ya, Sarifah.
Hello, doktor.
Ya, Sarifah. Apa dia?
Tak faham yang phasor diagram tu.
Yang tak pahamnya dekat mana?
Yang phasor diagram tu saya tak faham.
Oke. Ya, macam ni ya. Phasor diagram ya is a diagram that reflects to the voltage. What the type of the voltage is internal generated voltage, phase voltage, voltage drop of the synchronous reactance, and also armature resistance. Yeah, this one. And then exactly ini kena ingat ya, sebab nanti dalam tes ini ada untuk gak lukiskan. Ya, pertama sekali ya, the first you have to draw the phase voltage. Ya, phase voltage. Phase voltage ya is always reference. Ya, is always reference. Reference meaning the angle of the phase voltage is always zero. Ya, zero. Mana zero ya, you lukis in the horizontal axis. Ya. After that, look at the value of armature resistance. How many amps? Yeah, and then look at the type of the power factor. Leading, lagging, or leading. If the power factor unity, if the power factor unity means current IA and phase voltage are in phase. Ya, mana lukis dia ini, kalau ini dia punya tadi phase voltage, current ditimpa ya, in phase. Okay, and then if the current lagging, ya lags by berapa? Ya, lag mananya tertinggal ya, dia ke bawah. Ini dia punya current. How many degree inilah dia. How many degree ini carilah daripada power factor.
Doktor.
Yes, saya. Apa dia?
Doktor, saya tak boleh nak bayang.
Oh, bayang. Macam mana saya nak bayang? Saya pun tak pandai letak-letak dekat ini. Yalah, saya ulang dekat lecture note ya.
Sorry doktor, saya tak dapat nak.
Ya, tak apa. Tengok lecture note boleh lah.
Ulang kat lecture note saya okey.
Sebab saya tak pandai lukis-lukis dekat sini. Sorry lah. Mana dia? Where is power? Nih, ya. Mana yang unity? Unity dulu, dekat unity. Okay, unity nih. Okay, I repeat again. Yeah, when we want to draw the phasor diagram, the first you have to draw the vector phase voltage. Yeah, vector phase voltage. All yeah, for the unity, lag, and lead power factor. Yeah, and the power factor and the phase voltage is always as reference. Sudah? Is always reference. Meaning selalunya dia angle zero sehingga kita lukis pada horizontal axis. Oke, sudah ya? And then the second step, you can draw the armature current. Where is armature current? IA. Yeah, because it is unity, meaning the phase voltage and armature current are in phase. Mananya are in phase, sama-sama dia punya angle 0. Maka lukislah juga IA ini berhimpit dengan phase voltage. Masalah panjang dia berapa, ya ikut aja scale dia punya yang adalah. Ya kalau ini let's say lah 1 cm 20 volt, ya let's say lebih kurang macam itulah IA. Apa? Ya kalau saya yang penting dia tulislah dia punya panjang vektor berapa, macam itu ya. The that step for the value of IARA. IARA should be drawn starting from the end of the vector phase voltage. Ya lukis IARA bermula daripada ujung vector phase voltage dan dia punya arah mengikut the direction of the IARA follow the IA. Ya. Jadi mana saya kalau dia nih IA kan macam ini ya. Ini kan parallel with the phase voltage. Arahnya macam ini juga untuk IA RA. Ya. Nah, sama for the lagging power factor, kalau dia IA macam ini, si IA RA juga macam ini, dia punya arah. Maknanya angle ini sama dengan angle dekat sini. Oke, paham? Lepas itu, the next step you have to draw the vector JXSIA. Ya, vector JXSIA you have to draw start from the ujung daripada vektor IARA dan selalunya perpendicular. Ya, perpendicular. Ini ya. Jadi ini kan perpendicular dekat sini, yang ini kan perpendicular. Yang ini juga perpendicular kan? And then last kali vektor IA itu adalah bermula dari vektor phase voltage hingga ujung XSIA. Inilah vektor IA. Boleh paham? Halo, siapa tadi? Syarifah?
Faham dokter, terima kasih.
Serius. Serius
Faham
ini.
dokter,
Tes 3 ada
faham.
loh. Tes 3 ada.
Serius.
Oke, thank you. Oke. Kalau udah oke, kita lanjut untuk ini. Oke, soalan berikutnya yang C. What is the efficiency of this generator? Ignore the announced electrical losses when it is operating at the rated current 0.8 power factor lagging. Yeah, now so remember, please look at this one. Okay, diagram of the power losses. Yeah, diagram of the power losses. Meaning the generator operate starting from the rotor move, meaning given the mechanical power. Mechanical power is an input power. This one. And then last can be converted to be electrical. The last we have the output power is as electrical power here. During the operation, that there are some type of the losses. Stray losses, friction and windage losses, core losses, I power to R losses. In here. Now so efficiency is always P output over P input. Output power divided by input power multiply 100%. And then you can find the formula of the output power here. Yeah, source 3 line voltage, line current cos theta, and then it is depend on the I mean depend formula same. I mean which one same for the line current and line voltage. Yeah. Depend on the type of the connection. If the Y connection means line current is equal to phase current, and then line voltage is equal to source 3 multiply phase voltage. Yeah, if the delta means line voltage equal phase voltage for the current, line current is equal to source, yeah, source 3 multiply phase current, ya. Betul ya? Cek balik. Okay, this one. Nah, so and then remember, ya ini nanti saya tengok lagi. Because ada soalan pasal applied torque. Input power is equal to applied torque multiply mechanical speed. Yeah, this one. And then P compact is equal to induced torque multiply omega m. Ya, ini ya, this one ya. It means induced torque is equal to output power divided by omega. Ya, this one ya. Okay, now so we look at the question. Yeah, what is the efficiency? Efficiency is equal to output power divided input power. Yeah, output power divided input power. Now, so meaning you have to find the output power. Output power is equal to source 3 multiply line voltage multiply line current multiply cos theta. Yeah. And then it is for the 0.8 yeah, power factor lagging. Now, so please take the value phase voltage or line voltage for the power factor 8.8 lagging. Yeah. And then remember, when you use this formula, means it is the total power yeah, of the three-phase generator. Or if you want to find or you play in the phase, yeah, remember ya, sebab sometimes student terkadang silap-silap dia. If you use the phase, this one is just multiply by 3, just multiply by 3. If the line multiply by just 3. And then for this case, look at the type, also the type, look at the type of the connection, Y or delta. Okay, in this case, we use the phase. Yeah, phase. Now, so we can use this formula. The total output power is equal to 3 multiply phase voltage multiply phase current cos theta. Okay, and then phase voltage for 0.8, yeah, we have calculated. Yang mana tadi? Ini ya, 336.8. Ya, 336.8 nih. And then line current, because why? Line current is equal to phase current, dia sama, 60 amperes, inilah dia. Lalu cos theta, because it is lagging, the angle is minus. Ya, cos theta, ya cosinus 0.8. Ya, jadi cosinus minus 36.87. We give minus here because lagging ya. Now, so we have obtained the value of the output power is 34.1 kilowatt. Yeah, this one. Okay, and then input power. Yeah, yeah. If it is the input power and it is output power, yeah. From here to here, we have the losses, power losses. Yeah, power losses. So the output power is equal to yeah, P input minus the total losses. Yeah, or P input is equal to P output plus the total losses. Yeah, the type of losses have been given in the question. Yeah, for the mechanical and colossus. Yeah, mechanical is 1.5 kilowatt. Colossus is 1. Yeah, in this case, three losses is 0 and also electrical losses is 0. Yeah, output power here. Yeah, here. Now, so the total input power is 36.6 kilowatt. So the last we can find the value of efficiency. Yeah? Efficiency is equal to output power over input power multiply 100%. So 34.1 kilowatt divided by 36.6 kilowatt multiply 100%, it is 93.2%. Okay? Boleh? Okay, and then next question is calculate the subtorque. Subtorque meaning torque applied. Yeah, must be applied. Yeah, and then induced torque. Yeah, induced torque. Now, so the applied torque can be found from this formulation: input power is equal to applied torque multiply a mechanical speed, or applied torque is equal to input power divided by mechanical speed. Input power has been obtained from here, yeah, 36.6 kilowatt or 36,600 watt divided by omega m is also found, yeah, from here 104.7 radian per second. So it is divided by 104.7 radian per second. So we obtain the applied torque is 349.6 Newton meter. Okay, and then induced voltage. Yeah, induced voltage. Yeah, we can obtain from the formulation convert power is equal to induced voltage, induced torque multiply mechanical speed. Yeah, in this case, meanings we observe for the maximum power. Maximum power means convert power is equal to maximum power is equal to output power. Now, so induced voltage is equal to convert power divided by mechanical speed. Yeah, convert power is equal to output power. Output power is 34.1 kilowatt or 34,100 watt. This one, yeah, divided by mechanical speed is equal to 335.7 Newton meter. Okay, this one. Okay. Okay, last we want to find the voltage regulation. Yeah, voltage regulation, the general formulation is equal to no load voltage minus full load voltage divided by full load voltage. Yeah, and so you can find each voltage regulation for the each type of the power factor. Yeah, for the case lagging. Remember full load in here, yeah. And then if you use this formulation, if you use the pace, all the pace, no load, pace voltage, and then full load pace voltage. If you use the line, use the no load line voltage and full load line voltage. Yeah, in this case, we use the line voltage. So, lagging case, voltage regulation is equal to full load line voltage is 400. I repeat again, no load line voltage, ya, 480 volt minus full load line voltage, ya, 410 kan nih, mana tadi dia, 410, ini ya, 410, this one it is for the lagging power factor, ya, nah so 480 minus 410 divided by no load full load line voltage 410, so 17.1. Okay, ini sama lah, is different only in the type of the power factor ya. This case it is for the unity 468.3, 468.3 from here. 468.3. And then this one is 535 from here for the leading power factor. Yeah? Now, so last we can obtain the value of the voltage regulation 480 minus 535 divided by 535 multiplied 100%. Okay, look at this one. It is negative value here. Yeah, the sign is negative. It is indicate that the power factor is leading, meaning the terminal voltage here is higher than the meaning the full load. Yeah, full load terminal voltage is higher than the no load terminal voltage of the synchronous generator. Hey, okay. Oke, ada apa-apa lagi? Ada soalan? Apa bang? Bang? Syarifah, Kaltum, Ahmad Akif. Ahmad Akif?
Tiada, sir.
Tiada.
Ya.
Kalau tadi semua bangun, semua bangun. Bangun dari tidur, ayo. Saya nak tunjuk tip. Hint.
Dah bangun, sir.
Udah bangun?
Ya.
Ya.